All right, page 3 starts with Unit 6, which was about simplifying radicals. So you're going to need your perfects list for this, your squares, your cubes, your fourths. And I have a square root to start with, so I want to split this into 2 square roots. The number 32, if I look at my squares list, 16 is the biggest one I can divide by, so 16 times 2. I want to divide my variables by the root index, so it's a square root. I want to divide them by 2. 4 does divide by 2, so I'll keep it all there. The 9 does not, so I bring it down to 8, which means the extra y has to go in the second one because it still does have to add up to 9. Okay, so square root 16 is 4. Divide your variable powers by 2, you get x squared and y 4, and then the extra square root is 2y. Okay, so that's the first one. Second one is a cube root. So for the cube root, I need to separate it into 2 cube roots. Now let's see, 64 is actually on the cubes list, and negatives are allowed for cubes. 10 does not divide by 3, so let's bump that down to 9 and put an extra 1 here. So the x's are accounted for. 21 does divide by 3, so we'll keep it all there. Okay, so negative 64 becomes negative 4 when I cube root it. 9 divides by 3. 21 divides by 3. And then the extra one is just cube root x. It's also possible you get a fourth root on one of these, and then you'd also just have to look on the fourths list, and you'd have to make sure you're dividing your variable powers by 4. So all the same concepts apply. Okay, if you have 2 exponents side by side, you're going to add them, so this would be x to the 5/3. So then the denominator 3 equates to a cube root, and the numerator 5 equates to a 5th power. So that's the conversion there. And then because 5 does not divide by 3, I do want to split this into x3 and x2, both cube roots. All right, so now this one solves. 3 divided by 3 is 1, and then this extra one just stays. Okay, so if you have side-by-side powers, you need to add them, and then you just convert it with the root index from the denominator and the power from the numerator. All right, 19 is a fraction, so I need to subtract my exponents. 9/4 minus 1/4 is 8/4. But 8/4 reduces to 2, so that's all there is to it. But you can imagine if this was 9/4 over 2/4, and then you'd have 7/4, in which case it would be more like this one. So I'm just going to hypothetically say that it was 7/4. I know it wasn't, but if it was, then I would have a fourth root of x to the 7th, which would mean that I need to split this into 2 fourth roots. One of them would be 4, one of them would be 3, so that I still have 7 x's, but then 4 divides by 4, fourth root x3. So if you subtract your powers and you get a whole number, that's great. But if you don't, this is how you would handle it. Okay, so multiplying 2 expressions like this, because there's no pluses and minuses, this is not a FOIL situation. Just 3 times 6 is 18. 6 times 8 is 48. So the 18 stays here. 48 is going to split. If you look at your squares list, 16 times 3 would do that. And so I have 4 from solving the 16. 18 times 4 is 72, root 3. All right, let me change this a little bit. Let's say I had 3 plus root 6. I'm just going to do a slightly different problem. 3 plus root 6 and 6 plus root 8. Let's do 6 minus just to mix it up. 6 minus root 8. Now it's a FOIL situation. Okay, so 3 times 6 is 18. 3 times root 8 is negative 3 root 8. Root 6 times 6 is plus 6 root 6. And then 6 times 8 is 48 inside a root. So I would do the same thing here that I did with this 48. So that's going to be 16 and 3, so that's 4 root 3. Also, this 8 splits into 4 and 2, so 3 root 4 root 2 would be 2 times 3 is 6. So I have 18 minus 6 root 2 plus 6 root 6 minus 4 root 3. So if you look at all of this, nothing can be combined. Because in order to add or subtract radicals, you must have the same exact radical. And none of those do. So just so you're aware, if there is a FOIL situation, that's what you would do. Okay, now in this next one, again, there's no pluses and minuses, so I'm just free to reduce. So if I reduce 8 over 4, I'm going to get 2. I have a cube root, and then I try to reduce this too. So 144 over 3 would be 48. 15 over 5, it's not division, it's subtraction when we're talking about exponents, so that's x10. Okay, so now I have a cube root, so I need to look at my cubes list. And that's going to give me an 8 and a 6. So before we were doing 16 and 3, but that's the squares list. The cubes list is 8 and 6. So then I look at my exponent, can't divide it by 3, so I bring it down 1 and leave the extra 1 here. Cube root 8 is 2, times this 2 is 4. 9 divides 3, that's x cubed. And then the extra cube root, 6x. Okay. Next row. So we're solving radical equations, and we have to look at the root type in order to know what power to use to cancel it. We do that on both sides. A power and a root will cancel each other and leave just the inside. And then the other side is 4 cubed, which is 64. And from there, it's just 2 steps. I'm going to subtract the 1 and divide the 7. And putting the 9 back in does not create a negative. Well, it doesn't matter because it's a cube root anyway. So that one's good. All right, 23. I need to square this time, both sides. And the reason I'm squaring is because I had a square root, and so I need to cancel that. So I have 12 minus x equals x squared. Because I have an x squared, I'm going to need to factor, which means this side needs to equal 0. So I would add the x over and subtract the 12. Quick factor it. 4 and 3 should work. Put a plus on the 4 and a minus on the 3 so it adds up to plus 1. And then solve it. So x plus 4 equals 0, negative 4. X minus 3 equals 0, so positive 3. When you put negative 4 in, though, you get 16 under here, but then you also get equals negative 4, so that's not right. So only 3 works in this problem. Okay, number 24. I have a square root again, but it has to be isolated first before I can do anything with it. So the first step is to move the 18 over. Keep the negative 4 and the root at this point. Subtracting 18 gives me negative 20. Now I'll divide the negative 4, so I have root 43 minus 3x divides by negative 4, so that's positive 5. Now I'm ready to square both sides. And that's going to cancel out my square root, 43 minus 3x. 5 squared is 25. So let's subtract 43. That gives me negative 18. Let's divide the negative 3 and we get 6. 6 is fine because it doesn't create a negative square root. Okay, so anytime we're facing an equation with a root in it, we just need to raise it to a power that cancels the root, but also we need to make sure it's isolated first. All right, find the inverse. So the whole key to inverse is to switch x and y. So if it's just coordinates, all you literally do is switch x and y. So the first coordinate becomes 5, 3. Second coordinate becomes 8, negative 2. Third coordinate becomes negative 1, 7. No signs changed. All that changed was the location. Okay, if you have an equation, we're going to put a y in first to make it easier to do the algebra. We'll switch x and y. and we'll solve for y. So I need to add 9 first. Then I need to divide by 2, so y would equal x plus 9 over 2. And then I need to make sure it looks like an inverse. So f inverse is the way I write that. And it's x plus 9 over 2. If I were to have had a g, I would have written g inverse, so it just has to match. Okay, so we'll do the same thing here. Put a y, so we can do the algebra. We switch it to x. We'll try to isolate the y, so we'll add 10. This time I need a cube root to get that cube off. So if I cube root, I'll have y equals cube root x plus 10. So then f inverse equals cube root x plus 10. All right, so that'll do it for the inverses. So let's go on to page 4. All right, we're doing some graphing here of a radical. So recall a radical equation has an endpoint if it's a square root, and it's going to have to be, we have to examine that shift to figure out where it is. So a normal square root equation would start at center. This is shifted left 4 and down 2. So we need to put a dot at the left 4 down 2 spot. And that's our starting point. Okay, now to do this graph, we need to remember our movement chart. So this is not coordinates, this is how far it moves. And in order to do that, we use square numbers. Because it's a square root, I want to be able to plug in square numbers. And if you do square root 1, you get 1. If you do square root 4, you get 2. If you do square root 9, you get 3. Okay, so this tells me how far to move off this start point. It is not finding those coordinates. So I want to move 1 to the right and 1 up. I want to move 4 to the right and 2 up. And then 9 to the right and 3 up. So all of these red dots are the movement off of the blue dot. Okay, so then we connect those up, put an arrow on the end, and we're good with the graph. So domain is going to be from this blue dot to the right. And I need to include that number because it was an endpoint. So I'm going to include -4, and I'm going to go off to infinity. For the range, I need to include -2 and go off to infinity. So I'm starting at 2 and going up. Because it touched that dot, I need to show that with a bracket. Okay, the end behaviors, one of these needs to be showing that it comes to a stop here. So as x goes to -4, f of x goes to -2. Then we can go to the other side. So as x goes off to positive infinity to the right, f of x is going to go up to positive infinity, continuing up this way. So one of those lines needs to show the endpoint. Increasing, it's increasing the whole way. So it's increasing for the entire domain. No, we don't use brackets for increasing intervals, but from -4 to infinity. Again, these intervals have nothing to do with the height. I don't care that it's at -2. What I care about is that it's at -4. Decreasing, there is none. So just write none. Okay, 29. Cube root. Let's do the shifting first. So that's going to be right 2 and up 1. So right 2, up 1 is here. And a cube root graph is going to make like an S shape. So to do a cube root graph, our table needs to be using the numbers -8, -1, 0, 1, and 8. And the reason we're using these is because these are cube numbers, so I'm able to cube root them and get -2, -1, 0, 1, and 2. So that's my movement. I go left 8, and I go up, nope, down 2. Left 8, down 2. Then I go left 1 and down 1. I go right 1 and up 1. and I go right 8 and up 2. And for both of these graphs, square roots and cube roots, if you were to have a stretch factor in front, that would go on the y column. So if I put a 2 here in front of this equation, I'd have to also put a 2 here in front of the y, because it would double the outputs. So just be aware of that. Okay, let's go and do the rest of this analysis. So domain here has arrows at both ends. Hopefully your graph hit more of the dots than mine did, by the way. Negative infinity to infinity. Range also negative infinity to infinity. There's no boundaries on a cube graph, just keeps on going. So as x goes to the left, f of x goes down. As x goes to the right, f of x goes up. Had this been a negative in front, the graph would have gone the other way, and then these would have been reversed. All right, this thing is increasing at all times, and it's never decreasing. This will be one or the other in a cube graph, because it doesn't change directions. Okay, more graphing. Now this time, we have an exponential, so we are not using a movement chart. We're going to try to find specific coordinates. So the first thing I'd like to do with this is get the shifting right. So this is to the right 5, and this is down 4. So we'll keep that in mind. Also, I want to build off of the equation 3 to the x power. So I want to use exponents from -2 to +2. So all 5 of those numbers will be plugged in for x. When you put a negative up, we get a fraction, so 1/9. -1 would be 1/3. 0 is 1. First power is 3. Second power is 9. Now we have to look at the shifting. So it's moving to the right 5, which means I need to increase my x's by 5. And it's moving down 4, so I have to decrease my y's by 4. So I go back to my original numbers. -2, add 5 is +3. -1, add 5 is +4. 0, add 5 is 5. Then 6, then 7. -4, so I start with 1/9. -4 is -3 and 8/9. Calculator's fine if you want to make that a decimal. 1/3 minus 4 is -3 and 2/3. 1 minus 4 is -3. 3 minus 4 is -1. 9 minus 4 is 5. So there's my new points. It's not movement, those are my new points. Before I graph them though, let's get the asymptotes on there. So you recall that with an exponential graph, there's typically an asymptote across 0. However, that asymptote can be shifted up or down. So the one that applies here is this down 4. You can't move an asymptote that's horizontal to the left or the right. That's not going to make it move. So only if there's a down or an up shift. All right, back to plotting points. So +3, +3, -3 and 8/9. Barely above -4. +4, -3 and 2/3, a little higher. +5 is -3. +6 is -1. +7 is 5. Connect those. We have our exponential curve, and that curve should approach the asymptote line. Okay, with the exponentials, the domain is infinite. And the range has a bottom floor here. So -4 to infinity. I do not want to use a bracket here because it never touches that line. For end behavior, as x moves to the right, that right arrow is pointing up. As x moves to the left, that down arrow is not allowed to go down beyond -4, so it's approaching -4. The asymptote for one of these is horizontal, so we write y equals, and it's y equals -4. Okay, now if you were asked to do a log graph, before I leave you on this one, if I was to do a log graph, I would still use the base, but it would be in a subscript. So let me just write an example of that. If it was f of x equals log base 3 of x plus 5 minus 4. Okay, so I'd have base 3, which means I'd still make a 3 to the x table. The only difference is I'd have my exponents in the y column, and the answers would go in the x column. I'd look here for my shifting. I'd make my new table, but this asymptote line would run vertically. And it would run vertically at 0 normally, but this one would be a left shift, so it would be over here. Okay, so just so you're aware, log graphs work in the opposite fashion. All right, that's it for page 4.